Didik TV KPM.
For this segment, Sean, we will go through two chapters.
Okay.
One is probability, another one is probability distribution.
All right.
So I start with probability first.
Okay.
Okay. This is the most difficult chapter among students.
All right.
Okay. Because they are unable to differentiate between combination and permutation, using correct formula related to the correct events, and then they cannot use a probability statement with correct set notation.
Okay.
Let us see here. Okay, for this chapter, they must know well to explain three of the main terminology. Okay, one is mutually exclusive events, another one is independent events, another one is conditional event. So I will go through one by one all the events in this chapter and all the related formulas.
Okay.
Okay, first one is composite events. So here we got three main formulas. As you can see, Shauna, very clearly is written there.
Yeah.
Okay. So next one is mutually exclusive events. Students should be able to explain what is mutually exclusive events. Here we got all together 6 different formulas,
Okay.
which you should be able to use in context of the question. Later we will see in example. Okay. Our third event is independent events. So here we got 2 formula, which students should able to interpret and use it well, according to the situation.
Okay.
And next event is conditional event. For conditional event, we got 2 main formulas. Okay, and last event where students study is rules of total probability. Under rules of total probability, you got 1 formula, but if you don't like to use this formula, you can use 3 diagram.
Okay.
Much more easier to get your answer.
All right.
Okay, but what I noticed so far in my experience of teaching, students always show weakness in translating or converting probability statement into set notation. Once you convert to set notation, you can use a proper formula to find the value.
Okay.
So let us see some of the important. Before that, let us see how to prove 2 events are mutually exclusive or independent. Okay, first one is mutually exclusive. Okay, to prove 2 events are mutually exclusive, you can use either one of the 4 ways. Okay, student can see clearly in the boards one of the 4 ways.
Okay.
Or if you want to prove independent events, you can use either one of the 3 formulas. Either one enough already. Okay, you can prove. But once come to the next part, okay, set notation for probability statement, of course, student shows very weakness. Okay, Sean, this one is, of course, most of the student cannot do.
Oh no.
Okay, so let us see some of the main terminology. Okay, let's say probability of A and B. So this one is indicated by A union B. So the set notation we use here is union.
Okay.
Okay, which stand for OR. Next one is probability at least one of A and B occur. So for this, at least one, that means the set notation still remain the same, A union B. If you notice, different terminology, but the formula still remain the same.
Yes.
Okay, next, probability A and B. So the key point here is N.
Okay.
So this is indicated by A intercept with B.
Okay.
Then probability of both A and B. So the key word here is both. So we get same set notation. Probability of A intercept with B. Next, one of the event. The key point here is one of the event. That means only A occur or B occur.
Okay.
So which can be shown by using the formula PA intercept B prime plus PA prime intercept with B. Next one is probability both A and B does not occur. So clearly can see both A and B does not occur.
Okay.
Okay. So here we can see very clearly A intercept with B. Why A intercept with B, Sean? Because of the both.
Yes.
Does not occur, prime.
Prime. That's right.
Okay, then we continue. Next one, neither nor. Okay,
Okay.
neither nor mean here very clear. Okay. A union B prime. So you can see the difference. Both A and B does not occur and neither A or B. Slightly different. Okay, the last one is probability A given that B. So this is actually come under conditional.
Yes.
Okay, under conditional, this one is A, probability of A slash with B. Okay, let us see one example, Sean. Okay, one example where I try to apply all the probability statement.
Okay.
Okay. Two events, X and Y, such that the probability is given. Probability is given. So once you see like this, of course, you know this is conditional events.
Yes.
Okay. Then question is, find the probability that. Okay. The key point is here. Okay. So the key point is here, both. So once students see the word both, they should be able to use intersect. Okay. Then next one, if you notice B, they ask you to find both do not occur. That means if you don't know the formula, you cannot answer this question.
I see.
Then next one, only one of the event occur. So to answer these three part of the question, you need to convert the probability statement into set notation.
Okay.
Okay. So let us see. Question A, because both, so I use A, probability X intersect with Y. Okay, so I use the main formula. So this one you get from just now formula. I
Yes.
list all the formulas.
Okay.
So we substitute 3 over 4 times with 1 over 2. And then we get 1 mark there. And then my answer, 3 over 8, I get 1 mark. So
Okay.
you get 2 marks. Very straightforward question. But the condition, you should be able to convert the statement.
Okay.
Okay, next one. You want to find, based on the statement is, P X prime intersect with Y prime. Okay, so for this, our formula, we use formula based on what I told you just now. So we use the formula, and then you get 1 mark by using correct formula.
Okay.
Maybe you're wondering why you never get here formula, because very few marks.
Okay.
So depend to the mark. Okay, total mark awarded. So here we use this formula and we substitute the values, all the values, and then we get answer is 17 over 57, 1 mark.
Now I have a question over here. We see
Yes.
for part B, right? The first 2 lines over here, we show the formula. What happens if we don't show the formula and straight away just show the values or put in the values?
Thanks, Sean. Okay, if you never write these two formula, but you got substitute inside the formula correctly,
Yes.
without any mistake, the mark can be embedded here.
I see.
So this mark actually will go here.
Okay.
The mark will go here.
All right.
Okay, Sean?
All
Okay,
right.
we continue?
Yes.
Okay, in question C, we want to find neither one. Okay, so P X intersect Y prime plus with P X prime intersect with Y. So we use correct formula. So you using, because this is considered difficult case.
Okay.
Difficult, so you get 1 mark for using correct
I
expression.
see. Yes.
If you don't know to use the set notation, that means totally you will be wrong here.
Okay.
Okay, then we substitute inside the formula correctly, we get 1 mark. And then my answer is 9 over 28, which will give you 1 mark. So total here is altogether 2, 3, 3, 8 marks.
All right.
Okay, we continue, Sean. Okay, our next chapter is probability distribution. This is the longest chapter in the syllabus. Okay, longest chapter and more frequently will come out in session B. So in this session, for this topic, we got 5 different parts. The most easiest is the first part,
Okay.
discrete random variable, DRV. For DRV, is actually the very basic. Okay, you should able to use the properties of DRV. Next part, you should be able to calculate probability using PD and CDF, and then you should be able to obtain CDF from PD and PD from CDF.
Okay.
And then at last part, must use correct formula to evaluate or calculate mode, median, variance, and standard deviation. So this one is much more simple because we only use here summation mostly.
Okay.
Most of the cases we using summation. The next part of the chapter is continuous random variable, CRV. For this, Sean, if your integration, which you study in second sem, is very poor, then you cannot answer question in this part.
Okay.
This is basically is involving integration.
Okay.
Okay, calculus, what you study in sem 2. Okay, so for this one, first of all, you need to know the properties of CRV. Okay, 2 properties. And then you should be able to obtain CDF from PDF and PDF from CDF. and then calculate probability based on integration of PDF, and then use graph in the case of linear function, and then you can use CDF. 3 ways to obtain your probability. And then the next one, you should be able to calculate median, quartile, mean, variance, SD by. Here we got 4 steps. First, you have to define the formula correctly with correct limit of integration. Second thing, you must do your integration properly. And then next one, you should integrate and substitute your value. And the last part, you will get your answer. Okay. Next one, we will study 2 types of distribution which come under DRV, binomial distribution and Poisson distribution. These 2 are considered slightly easier. So here you should be able to define condition for a random variable x for having binomial distribution or Poisson distribution. And then able to define the correct formulas. And then able to find mean and expect a mean and variance using the correct formulas. And then the last part, you should be able to solve problem involving this distribution. But when solving problem involving this distribution, you have to state your random variable, state your distribution, list your probability one by one, and use correct formula to evaluate them.
Okay.
Okay. The last part of this chapter is normal distribution. In normal distribution, you got 2 things. One is to solve problem related to science and science and technology. And for this, you have to define your random variable and state the distribution. You need to use correct symbol of inequality involved and standardize. Okay, next, you should be able to sketch the normal curve and shade the required region. And show the correct usage of CDF. Here shown, mostly students never write this thing.
Okay.
They tend to use calculator and lose mark. Mark is deducted. Okay?
Alright.
And next thing, determine the probability by using table or calculator. In next part of this chapter, we will use an approximation for binomial distribution. That means we will use normal distribution as an approximation for binomial distribution. Almost identical to just now, but slight different. So first, we have to define the binomial distribution. Next part, we have to show the transformation of the distribution. That means we will transform from binomial distribution. We will transform from binomial distribution to normal distribution by stating the condition and calculate the mean and variance.
Okay.
Then after that, it's all follow exactly like just now. No
see.
different at all here. So you have to sketch the normal curve, shade the required region, show the usage of CDF, and last, you have to determine the probability by using table or calculator.
Okay.
Okay, we see one example here, Sean. Okay, this is one long question which come out in session B.
Okay.
15 marks.
Oh.
If
oh,
you can
that's a
answer
lot.
this one question, is considered very good already. 15 marks out of 60.
Wow.
Okay.
Okay.
So the mass of guava, okay, is given something like that. So the percentage of guava that are less than 400 gram is 15.87%. More than this one is this 6.68%. Okay. So determine mu and lambda. And find probability that guava has a mass at most 500 gram given that it is more than 400 gram. And then in next part, this is got one officer, he go and do something. Okay, so he said that the number of guava in the branch of the tree may be modeled by a Poisson distribution. May be modeled by a Poisson distribution.
Okay.
Okay, so Poisson distribution, he gives that Py0 is equal to this one. Find the parameter of the Poisson distribution. If the student don't know what is parameter, they cannot answer this question. Okay, students should able to understand what is parameter.
Alright.
Okay, then give 2 reasons why Poisson distribution cannot be an exact model. Here we do with Poisson, but here we say why cannot use Poisson.
Okay.
Okay, just explanation. Okay, so the keywords are this is the one. Okay, parameter, reason. Let us see the solution. Okay, I back to just now. Okay, if you notice, Sean,
Yes.
we got here mathematical probability statement. Probability statement, probability statement, where
Yeah.
student have to convert into symbols.
Okay.
Okay. So first, they write x is less than 400. The probability given 15.87, so become 0.1587.
Yes.
Next one, greater than 500, you get something like that.
Okay.
Okay. So once you can convert the statement into mathematical symbols like this, you get your first mark.
Okay.
Okay. Then of course, just now I mentioned to you. Okay, just now I mentioned to you that you have to standardize.
Yeah.
That means here also we standardize. We have to show this, Sean.
Okay.
Okay, standardize. Then here also we standardize because both are we doing the same things. So 1 mark is given here.
All right.
But both must be correct.
Okay.
Okay, next, what we do, as what I mentioned earlier, we sketch the normal curve. We mark the indication here. Then we get my value here is equal to -1.
Okay.
So that means I know this whole thing is equal to -1.
All right.
Okay. Then same thing I do here. I draw the diagram. And then I get something like that. So if you notice here, Sean, the student must get here -1 and form one equation here. That's
Okay.
why you get 1 mark here.
I see.
Here, you have to form one more equation based on the value 1.5.
Okay.
So you got 2 equations. So they need to rearrange the equation. So from here, we rearrange. Okay, this one we rearrange. We got 2 equations here. Okay. And then what we do, we need to find the value. We got 2 simultaneous equation here.
Yes.
So we have to solve the simultaneous equation. We show the method. Then we come to our answer. Mu is equal to 440.
Yep.
And then my
Lambda,
sigma is equal to
sigma,
40.
sorry.
Sigma is equal to 40. So 1 mark here, 1 mark here.
Okay.
Okay. So if you notice here, Sean, changing into the probabilistic statement into a symbols is very important, as what I mentioned earlier. Okay. Standardizing. Okay. Using correct diagram here, then get your answer.
Okay.
Okay, in part B, we asked to find probability.
Yeah.
If I go back to earlier part, if I just want to show the thing to you, Sean.
Yeah.
Okay, if you notice here.
Oh, back to the question. Yeah.
So if you notice here, find the probability that guava has mass of at most 500 gram, given that, if you still remember just now, I got used the
conditional,
word.
right?
Yes, conditional, correction.
Yes.
Okay, given that. So that means this is a conditional statement.
Okay.
So we must use, go back. So I have to convert my statement into symbols.
Okay.
Mathematical symbols.
Yes.
So I use correct formula here. Okay. So convert the statement using correct formula here, mark is given.
All
using
right.
correct formulas.
Okay.
Okay, next. Of course, here I need to do standardization.
Yes.
But in the question earlier, they already give probability for x is 400 and x is 500.
Yep.
So we no need to standardize the things. So we can use formula here, the diagram.
Okay.
Okay. So what happened? I interpret from here because you want to find probability for this. So all together is equal to 1 minus with this probability and minus with this probability.
Okay.
Okay. Because these values we already given.
All right.
Already given. So I substitute inside because from year to year no marks because we just applying only.
Substituting
Okay.
yes.
So we substitute correctly all the values, we get 1 mark, and then my answer I get 1 mark.
Okay.
Okay. Then the part C. In part C, okay, they give you this one. They ask you to find the parameter, but students should understand that parameter mean because this is Poisson, you need to find lambda.
Okay.
You need to find your lambda. Okay. So your lambda here, so we use the formula, useful result. This is I call as useful result. So use useful result, you get e to the power of negative lambda is equal to this one. Then we try to solve it. Okay. So we use ln. Okay, we solve. And then we get answer 2.35. Okay, Sean, I go back here one more time, Sean.
Yeah.
I get my exact answer here is 2.35.
Okay.
Okay. If let's say the student write 2.4 because he round up here,
Okay.
your answer will be wrong. Because I told you just now, numerical value must be at least 3 significant figures. 3 to 5.
3 to 5.
3
Yes,
to
that's
5.
right.
So
yeah.
the best value is 2.35 because after this all 0.
Yes.
Okay, so this is the best answer. Okay, next. Okay, they ask you to give reason. So if I mentioned earlier, for binomial and Poisson distribution, you should be able to state their conditions.
Yes.
Okay. Condition for what is properties of Poisson distribution. But in this case, they are asking, why never follow a Poisson distribution? That means you must find the negative statement for that.
Okay.
You must find negative statement. So what happened? For Poisson distribution, if you notice here, in guava trees, the branches won't be equal in length.
Yes.
For Poisson, everything must be equal in length.
I see.
So, if you write, okay, branches, the key point here is not equal in length. You will get 1 mark.
Okay.
The next one, for Poisson distribution, the properties is Poisson distribution can go until infinite. But in guava tree, in a branch, the most we can have is a finite number of guavas.
Yeah.
We cannot have until infinite number of guavas. So that's why the second reason is finite.
Didik TV KPM